Great to see you. Thank you for, I guess, choosing to be the first guest on our engineering-driven podcast here at Nutrient. Why don't we start off with just some introductions? I'll start. I'm Jonathan Rhyne, the CEO and co-founder of Nutrient. Why don't you introduce yourself, Nate?
Yeah, so I'm Nick Winder, and I'm a engineer at Nutrient, in the core team and the AI team now. So kind of interesting.
Yeah, we're gonna dive into that story of how you went from the core team to the AI team and what that means a little bit here. Just looking, I think we'll probably spend most of today focused on, your background as an engineer, your path especially, because I think you have a really unique path. How you went from really a kind of traditional software engineer and now how you've kind of transitioned into being one of the lead engineers on our AI team. We'll talk a little bit about our current AI products. We'll probably leave that for a little bit for the end. I'd also love to just kind of hear what workflows you're using now that you've kind of been embedded there, and yeah, maybe some lessons and advice you might have for other engineers that are either skeptical or just starting out, or maybe the ones that are knee deep in it. So why don't we just start with a little bit of your, you know, a summary of your engineering path, how you got into it, and maybe even then dive into some early perceptions of AI and software in general.
Yeah. Okay. So engineering wise and software wise, it actually goes prior. It goes back further than software itself. So I started in music, and I started dabbling with electronics first, and that's actually where I went to university and got electronics degree with music at that point, and then realized there definitely isn't any money in music anymore. So I need to actually go into electronics itself. Luckily, at that point, I worked at a company which they just needed some software doing, and this was back in quite a while ago. So we were using Ball and C++ compiler, which is a very old compiler. And yeah, that actually led me into embedded engineering first. So I still wasn't a typical software engineer at that point. Um, but I kind of evolved many times, going to a few different companies, and ended up in software engineering, pure software engineering, mainly at PSP DevKit, which is now Nutrient. And it's kind of evolved along a path of electronics to software to low level software to high level concepts. And now we're in AI. So AI has changed things a lot, and I'm sure we can get into that a little bit more. Um, but yeah, yeah,
So why don't you tell us a little bit about what you did early days at PSPDF Kit? What were you working on? Maybe what languages you were working in? Problems you were solving, and kind of some just thinking about your early days and years at PSPDF Kit.
yeah. PSP Dev So C++ mainly. So working on the PDF engine, and that meant fairly low level, which I was kind of familiar with, especially from the embedded engineering background, at least anyway. And at that point, it is basically testing, hacking away, trying to work out uh, complicated PDFs and why they don't render or why they don't do something. Um, I feel that we're definitely past those days. The document space is always tricky, and there's always non-conformant PDFs to play with, but the document space is a lot wider now, and we play with a lot more technologies in general. So at that point, still C++, but it also meant that we were playing with many different frameworks and environments as well. So having to support like Android, iOS, web in the end as well. There's so many different environments that have a lot of intricacies that were difficult, and you're not basically siloed, or what we weren't siloed into our little C++ world. We had to be general engineers to be able to actually try and debug in all these different environments. And I had a bit of a Java background. I didn't have a Objective-C background at all. That was hard. You just learn it, and you end up trying to solve the issue at hand. So yeah, at that point, it was definitely all hands on deck. Try and work in any environment you can. Um, yeah, so it was fun days.
One of the things I always loved about you here is that you were never afraid to kind of take on a new challenge. And, I remember early days when we were trying to figure out OCR and we were getting questions from people like, hey, can you guys do OCR? And, oh man, that was really complex. And I got told even from my previous founders, like, oh, hey, there's no way we're going to build OCR, it'll take us 2 to 3 years to build it. And you decided to just do some brief, maybe research and ultimately build our first quote unquote OCR solution. Why don't you tell us a little bit about, that journey and what you did there, briefly? And I think it leads in great to kind of how you're now doing it with AI at the company as well.
Yeah, okay. So I think that kind of goes back to my engineering background in general is more of a hacker's mentality, I would say. So that started in music. And when I was playing with music, I was a guitarist and I liked different sounds. And in order to get different sounds from an electric guitar, well, you had to put it through a load of electronics at that point. Like now it's way different. And I know people still in that industry and it's a very different world. But I had to basically learn how to do electronics. And I understood when I tweaked this resistor on this transistor, it made a different sound. And it was basically just test. And this feedback loop just kept going and going. So I've definitely done this throughout the whole career. So I knew of technologies that did OCR, like Tesseract, obviously. Um, and we were a document company. Like we were able to extract information from a document. So we can create that iterative loop and come back and get feedback and say, is this good or not? Or can we offer a solution which is comparable with another OCR engine or something like that? So it's basically the fact of like at the start, hacking something together so you can prove it works, and that's super important. And then refining it at a later date. And yeah, a lot of features end up like this, and that's the way that things probably should be as well. You shouldn't over engineer things at the start, at least anyway. So
No, I think you embody, maybe a little bit of kind of the core engineering mentality, at the company, and this idea of like, okay, let's speed really fast and hack something together and see that we can provide value. Try to get it to customers to ultimately get that feedback loop, and then let's iterate on it, productize it, refine it, and then maybe even come back and refactor the original thing we did to actually work in a way that meets production level quality or production level speed, whatever it may be, that our customers, ask for and then request for. Um, that's a good segue. So, you know, I guess it's now been almost 2 years. If you really think about it, kind of crazy. Um, Tell us a little bit about the early perceptions you had when we said, "Hey, AI is coming. We need to think about this." Of course, there's the like AI is going to take over the world mentality. How did you view it? Hey, when you were first asked, even, hey, can you look into this? Can you potentially help us build a product around it? Talk a little bit about that.
yeah, okay. So my initial mentality, I'm sure probably a lot of engineers' mentalities, is basically what's this? A simple autocomplete. And that's what it was back then. Like it was an autocomplete for our code. Um, and it was similar for the English language as well, or just any language. So I did not see it too favorably at the start. I didn't really foresee what could happen. And I think mainly what that came down to, I didn't understand the fundamental tech behind it. And uh, that was ignorance, to be honest. Like it was just ignorance, and I hadn't actually done researched or hacked, like I just said a minute ago. Like I haven't hacked anything together to see what's actually possible. And I I can say that this is a mistake that I make over and over again, and I've made that many times throughout like my engineering career. Basically dismissing it based on previous experience, and that experience was incorrect or outdated. And I think this is a major issue where we're at right now. Is the the rate of change is so great right now that a lot of engineering experience is not exactly outdated. There are paradigms that we can take from our previous engineering experience, but a lot of the paradigms are shifting, at least anyway, and the way that we're approaching engineering issues and problems is definitely changing completely. And it's hard. It's hard to change. It's really hard to change. Like it's especially as you get a little bit older. It's really interesting working with younger engineers now because their thought patterns are completely different. And I can't even understand it sometimes because I would have to go away and reformulate the problem space or the issue that's at hand. And often, sometimes they would just basically run with an idea and solve it 5 times and then choose the best one. And previously, that wasn't an engineering technique that was it could work, but it took so long that often you would choose the least path of resistance, and that didn't always mean the best quality or the best product at the end of the day. So yeah, things are changing there. So eventually, there was a carrot on the stick, and I chased it because somebody put it there. And if you give me a problem, the same with the hacker's mentality. If you give me a problem, I'll try and solve it. It doesn't really matter what it is, and that's kind of the driving aspect of like my brain in general. Is like I like to solve problems, and yeah, in general, I like to solve problems. So there was a carrot and a stick, and I chased it, and I realized, oh, okay, this can change things. This will change many aspects in documents, being one thing, but now we obviously know it 2 years later or years later that it's going to change every single aspect of my job. It's going to change your job. It's going to change pretty much everybody's job. Um, we're still trying to filter down the areas of where that job will change and if we'll lose jobs. And I think that that's not something that I'm definitely skilled to understand, but things will change at least. We know that.
Yeah, you bring up a lot of stuff, and I mean, I've been in, I guess, software engineering since I started college, and even before that, that was kind of the way. My first, I like to say, I had a computer really early. I got on the internet probably when it was the Wild Wild West, and maybe I should have had more guardrails around the internet when I was younger. And then, ultimately through my legal career and, consulting with, representing a bunch of software developers and seeing this, you run into different types of software personalities, software developer personalities. And, I do think there are the like, I need to think about it theoretically, and the ones that are like, I'm just going to start and hack to it. There's ones that really focus and go deep on a language and then don't really wanna look at another language or another way, because that means they're gonna lose all this experience and speed and know-how that they've built on this current language. And we've seen a lot of, changes even in our time, especially in the last 10 to 15 years in software development, you know, from even going from a language like C++ to now you see very declarative languages became kind of nuanced. And now LLMs are kind of pushing something similar. And, the thing that's interesting for me is that I actually think there was this whole idea of how do we make software development or building easier for more people? Like, how do we make it more inclusive so it's not this super difficult thing? And, I love this because being a Apple fanboy as I am, like personal computing and ultimately the Macintosh was this idea of like, let's get out of the computer with only green font and a green screen that only these people in the corner that are nerds are using it. How do we make it more ubiquitous? How do we create a personal computer for more people? And so seeing it with ultimately, engineering and software development, you see that push. And we saw web development really kind of come back in 2017. WebAssembly was really big. It kind of really expanded what was possible. The actual hardware devices and how much memory you could allocate to be able to do some of this processing in a browser was also a step forward. And then it was like, ooh, LLMs, transformers. And this was like, well, we always kind of knew what AI and machine learning was. And all of a sudden it got way more sexier when it could understand, language and ultimately be able to interface with humans in the way that most humans interface with language, right? Instead of this like code language that we're having to translate our natural language into to be able to give instructions to the computer. And in my kind of way into AI early on really was with diffusion models. And it was really cool because, I like to say with AI, you kind of get three moments. Like the first moment is skepticism, right? Like the one everyone has, like, this is bullshit. This isn't going to work. Uh, and then you hit a moment where you like, prompt engineering, you get the prompt right, you learn how to interface with the LLM, whatever particular model you're doing. You learn the tricks and trade, and all of a sudden you're like, oh my God, this is amazing. This is going to completely change the world. Everything's going to be different. Oh, that's phase two, right? And then you ultimately hit phase three where it's like, well, shucks, I'm running into some issues, and this is not as great yet as I see it, but there's some lot of potential in it. Um, I'd love to talk about that turning point for you. What was the point that really shifted for you in that journey? And we can talk a little bit about what we're trying to build initially first, and really what we're building now. Because, like you talked about the rapid change, I think in AI, it's really crazy rapid change. But let's talk about that turning point for you. What was the part that changed your mindset, or what was that moment that took you from phase one skepticism to either phase one is going to change the world to maybe even phase three? Okay, I know enough to be to know where the problems are, type thing, right? Why don't we talk a little bit of that?
Yeah, okay, so it actually took quite a long time, I would say. So phase 1 was actually a long tail. And that's likely because we were a little earlier on some of the tooling interface. So as we see it now, we see technologies like MCP coming around, and then also just tool calling in general, which most models can basically do now. Um, Back in, well, it's still only a couple of years ago, if that. Back then, models weren't able to do this, so we were trying to communicate in our natural language, in basically a language that the model can understand, and that meant adapting our tools that we currently had, which is PDF engines or document conversion, anything like that, into something that the model understands at that point. That's tricky. That paradigm was probably wrong. There was no choice back then, but it was wrong. We needed to give the LLM or the model itself the tools to actually gather the information itself. And that was quite key. And I think that's where the turning point really was for me. Like I could actually start to see the um, the reasoning, basically back to it's that reasoning aspect, the reasoning that a model could actually make upon tool calls and the data that it was ingesting. And when you don't have to explain a concept to it and it understands a concept just from the data that's being gathered from the document, that's an aha moment. That's a massive aha moment. And I keep having those basically, even when the tooling is a little bit poor and you're not actually giving it the correct structured information that you would require as a human to actually understand what's going on. When the model actually finds a pattern and understands it, even without a visual representation, and goes, "Ah, yeah, I can work this out," and it gives you a response which actually you would come to by looking at a document, for example. That's an aha moment, and that's amazing. That's the phase 2 that you're talking about. Then you're kind of looking at trying to get into that production phase, and you need that aha moment to translate into 90x% of times, whatever the 90x is. And that is very difficult. It's very, very difficult because we know that we can't rely upon, well, we've got hallucinations, we have inconsistencies between runs. So you really have to, like you say, put guardrails up and understand how to actually filter this back into a response that works most of the time. And again, that's another shift in engineering. We're used to heuristics and logic, which can have a deterministic output all the time. We're not used to this fact that sometimes the response is going to be wrong. And how do you deal with that? It's just another thing that you do need to learn, especially obviously in AI and the current paradigm in general. So it took a while, but I'm there now. I understand. And I'm in that phase 3 where it's very frustrating that you can't get the reliable output all the time.
You hit on a few things here that I think is actually interesting to talk about with like some of the early use cases. So like obviously, we saw chat with your PDFs pretty early as soon as they opened chat GPTs, like plug in store, create your own custom GPTs and things like this. And being in the document space, we went there and go, okay, yeah, how are they understanding that information they're getting to ultimately to query it? Well, all those PDFs like we talked about when you were on core, sometimes it really the limiting factor is how much information can the GPT actually understand from the document? Because maybe the processing of documents poorly and it can't understand it. We also talked a little bit about, early days it was line chain and chaining these things. And now all of a sudden we have agentic workflows and MCP and it's like standard protocol to handle these agentic workflows. And yet you still are running into kind of these core problems you're talking about. It's like the core problem is how do I get the proper information from the document into the LLM so it understands it? So how do I explain what it is to the user or help them maybe explain better when they're inputting what they want to get an output that they're desiring? But then you also get this benefit you talked about of context and reasoning that pure deterministic logical algorithms maybe can't do. And this is like when we were working on, for instance, you were building out our redaction workflow and being able to use the AI assistant you built to not just give me a summary of this document, but hey, redact information. We had smart redaction that was algorithmic before, but how was that different now than using an AI to do it? And what were the kind of some benefits of using that AI to do that redaction workflow? And then also still kind of that 90x% problem when you're doing these redaction workflows. Can you talk a little bit about?
Yeah. So when thinking about redaction, we originally had heuristics. So the heuristic based model was basically we can identify numbers, we can identify addresses, we can identify these things. But the thing is with that it's obviously limited in scope and it doesn't take the use case into account. So the industry use case or the inherent deep knowledge that the actual user has. If we can take that and translate it into a language or a heuristic from the model to be able to actually search through content in a document and identify that content, then we can expand that use case massively. So one, you can expand the use case, but on the other side, you can also find areas which a simple heuristic just wouldn't have been able to identify because this is natural language again. So that was really interesting because it relied upon identifying the key aspects of the input to be able to actually build something in the model space, which could be used to actually identify redactions. But then at that point, we already knew that we were going to have either hallucinations or reliability issues. So we have to iterate back round and basically try and work out, okay, which one of these false positives are correct or not, and then what have we missed at the same time. So we ended up with kind of like a mixture of algorithms to be able to actually identify these redaction terms and create a little bit more reliability than what we would have had previously with simple prompting. Again, that's a completely different way of thinking. Previously, we could have tests, unit tests, things like that. And we had deterministic outputs, so we could easily test against that. Now we had a situation where it wasn't deterministic. We had to evaluate. And I'm sure most people have heard about evaluations in AI and how important it actually is. And I think the interesting part of that is you never get to 1 or you never get to 100%. You're still actually at 90x, like we're saying before. And it's playing with the internals to find out how can you push that figure a little bit higher. And well, that's what we did by introducing many concepts or little components into the redaction feature to be able to do that.
Yeah, one of the things I love you're touching on that I pick redaction because and this is talking a little bit about you personally. Like one of the jokes I like to say is it's Wednesday afternoon for me here in the East Coast of the US, and you are in New Zealand where it is Thursday morning. And the great thing about you working at our company is when we originally met, you were still in the UK, where you're originally from. You then moved to the US, got married to an American, and then all of a sudden you're now in New Zealand. And what that has, I think, shown you or you've had experience in that runs into a redaction problem is simple things like a phone number or an address, or even like a social security number in the US. The equivalent of that in, I don't know, the EU or the UK is different, and it's different all over the world. And so you would need, in an algorithmic heuristic way, to know, I don't know, how zip codes are done, how addresses are done in a certain country to handle that if you needed to redact, private information, right? Whereas now the benefit of that kind of LLM is it kind of knows what that word private means, and it kind of has more understanding or at least encompassing of what you mean when you say private. And so you kind of get this magical benefit of this context understanding and this, like you said, reasoning based on natural language that makes it solve maybe things that you would have to deterministically solve with an algorithm. And I think that's a great one. I love it's the tie into your story and kind of where you've been, but also kind of in the benefit and also the cons of both an algorithmic deterministic way of approaching a problem and this sort of contextual LLM, some sort of recognizing or probabilistic model reasoning. And that to me, when you touched on evals as well, which it is different, and I've always had this thought, with both, algorithmic, approaches as well as this new AI LLM approach, is that really the blend of these 2 is ultimately gonna lead to the best outcome, because I think there's certain problems that are better solved with this context that really have a value add, but then there's that 90x that you're never gonna get to 1, because I think one of the problems people struggle with AI, if you're brand new to it, is, well, this is the magic box that gives me answers and reads my mind and knows everything possible about what I'm talking about. So I can give it a 0 shot prompt, one thing, and it'll fill in all the blanks, right? It knows it, right? And in fact, that's where we kind of run into some issues is you still kind of got to know what you're doing, or you still kind of got to know the subject matter area to get the best output out of an LLM. Why don't you talk a little bit about that?
Yeah, I think that's kind of interesting for anybody coming into this that's maybe even not got a software background or engineering background, because it 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 is an enabler for those people with a deep understanding of the problem space, at least, to actually get some type of output out, which can be useful in the end. You don't need to know any software paradigms. You don't need to know any heuristics. You explain that in natural language, and you can get some type of response that actually makes sense, which is yeah, it's very powerful to say the least.
I think we can get the evals as well, because I think evals are really important now with how much we're seeing model driven improvements. And it's really now getting to the point that it's optimization of what the model is specifically trying to do. But I think it just goes back to this difference between, and you really kind of hit on it, deterministic problems that you definitely had to know very well what it was you're trying to do to be able to deterministically create an algorithm to do it versus something that you kind of need to know a little bit less, but then you're going to know whether the actual output is, good enough. And you do run into this sort of I like to say it, ultimately, often the LLM is trying to give you the response that it thinks you personally will find valuable enough. And that can be a little bit of an echo chamber and trap especially if you, like you said, if you come from this skepticism, it's going to be skeptical because it knows you're going to want a skeptical answer, right? Um, so yeah, just it really the question was more around like talking about this difference between this deterministic algorithm and ultimately what you need to know to be able to build solutions like that. And then this sort of LLM, let's say more murky or non-deterministical output that sometimes changes as these models changes or as your prompts change with it, and ultimately building software solutions to, help people solve problems in their day to day, and how those two have different pros and cons.
Yeah, okay. So I think this probably goes to the what is you need to be very well, I don't know, you need to understand exactly what you want out. And you probably need to understand that in natural language rather than in code and logic, which is usually what us developers are used to. We kind of convert that in our head naturally now to actually some type of algorithm or something like that. And being able to explain that back to somebody, especially if they're non-technical, is really, really hard. Well, that's kind of interesting where another use case of models is basically throw that into a model and you'll get a response which you can give to somebody that's non-technical. It's really interesting. But we now come to a space where if we're trying to create evaluations, we're likely creating these in a natural language format, at least anyway, and that will create the test case or whatever you want to call it to be able to determine if the output is good or bad. So it, you kind of flipping the development on its head a little bit. So understanding the problem space quite deeply and having a good understanding of what the requirements are is key to build this evaluation and the data set around it as well. And then working backwards through development instead. And often when this is test driven development, basically, often we developers didn't always do that. We developed the algorithm, whatever it is, and decided to bolt some tests on top. We're all guilty of it. We all do it. No one's perfect. It's really important to actually use that evaluation and test-driven development in the AI world because the output is non-deterministic, like we say. So if you want to gain confidence in anything that you're creating, then you want to know in many situations what the expected response will be. It's become a lot more important in general.
Why don't we pivot a little bit and talk maybe about your current AI workflows and how you use AI? And it doesn't just need to be in like building per se, but like what are you using it, and how have you found it to be, yeah, beneficial, and maybe opened your eyes and changed the way that you would do work now compared to the way you did work before? And maybe talk a little bit about those benefits and what you really it's been exciting for you to actually use these workflows and kind of reinvent the way you're doing work and thinking and doing that with an LLM. Why don't we talk a little bit about that?
Yeah, so there's pretty much everywhere in my life that it's definitely changing on a lot of aspects in my life, inside development, outside of development, and yeah, personal life. I think the interesting part is basically a lot of people are looking towards performance, and this often misses the aspect of quality. And I kind of feel that quality, the a lot of AI can actually improve our quality. And a lot of the tools that I'm using is basically enabling me to improve quality rather than actually increasing that performance. So in a software world, uh, I'm using AI tools every day to be able to create small implementations or iterations of a feature or even a product sometimes, and using that as a little test bed, say, and trying to prove out a problem or prove out a solution at least anyway, to see if that could work. And yes, that will not be the perfect output. That is likely throwaway code. And that's really interesting. We've never really had that concept before of throwaway code. And in the end, you will have, like I said before, those multiple iterations of solutions, and you'll probably choose aspects of each of those to create a production ready application or feature. So in my day-to-day, I use agentic AI kind of tools to be able to write code, to be able to refactor code, to be able to write a complete product. I've released my own products purely from my natural language in my brain, and I've not touched a line of code when I've released that, which is an unbelievable thing to think. It's also allowed me to upskill or learn different environments very quickly. So I think it's very obvious to most people now, but when you don't understand a concept or a line of code or anything, you don't go to Stack Overflow anymore. Like that used to be the thing. I predated Stack Overflow as well, but I used to have to ask my mentor to explain something. Then Stack Overflow came along, and you just basically went to Google and searched for that. Now we've got a model, and that model can usually explain fundamental concepts that you're seeing in code, which is it's beautiful. And you can then use that to be able to improve the code or improve your implementation. I often go back and iterate on parts of code now and just say, hey, what have I done wrong? What could I have done better? And that enhances learning and speeds up that iteration of working in a new environment. So very powerful just as a chat. And I don't think chat is really the most innovative thing in AI at all. I think it needs to be built into our tools in many different ways. But even just using chat is very, very important in everyday life now. We've got to the point where we're basically giving some type of product descriptions and actually producing an output which is a full product, which is absolutely amazing. And this comes back to the fact that a model can actually discover information by itself now using tools. And that's obviously what we're doing in the document space as well. We're using tools to build that context to be able to actually produce an output. These development tools are doing the exact same thing. And it's not just taking in a source file and trying to extend that anymore. That used to be the code completion aspect. Now we're getting to a point where it's using the same developer tools that we used to use on the command line, for example, and it's basically expanded its context to be able to produce a decent result. A couple of little things there is it's always nice to sprinkle in a few things to guide the model. Basically, stop commenting every single line. That's often a thing we see from these models, and it will point out the obvious. We've always been taught that as software engineers, don't comment something that's completely obvious, comment the difficult things to understand. A model can't quite get that yet, so you need to tell it. And that's it's kind of a funny aspect of it. But yeah, it's very powerful to improve performance. Yes, I agree, but quality. I think that's an aspect that people should focus on a lot more.
You touched on a few things there. Obviously, I'm not every single day in code, but the thing that's really interesting for me is the brainstorming assistant. Like, how can I use this thing to think better with it so that I can create a better output than if I wasn't thinking with it? And it can discover unique ways that you never thought about. It can show you multiple different ways, and then you can pick one or two of them that you think, I really think this is a powerful accelerator that AI has brought to all work. And I would agree. Definitely in the software developer range, like industry, as well as anything, whether it's content creation, whether it's research, whether it's analyzing stuff, or whether it's just, hey, I want to learn how to do this. Can you help me do it? The other thing I think you hit on a little bit is this idea of like, what can it do that I needed to do before, but maybe was work that I was annoyed doing or it always was cumbersome for me to do. You talked about commenting. Well, the classic problem you have is if it's a piece of code that you write and you don't ever anticipate anybody else looking at it, you kind of never write any comments, right? Because it's just extra shit you need to write. And then you have like, this tooling that like, oh man, you're explaining things way too much reading. This doesn't need to be said, things like that. But, the mix of these two ultimately is, hey, somebody might need to look at this. I need to explain what's going on here. And now this thing can write me a paragraph that explains it pretty well, and it's a really great comment. And now it's easy for me to implement that in there. So it's both from a help me understand this piece of code, and hey, I just wrote this, help someone else understand this that might traverse it later. You talked about testing, and I think this is probably the one that most software engineers, at least using Copilot, have really jumped on. Is like, I hate writing tests. This thing can write tests for me, and they're pretty good, right? The context of the understanding of what it's going on, and this is way faster, and therefore I'm more likely to write tests in my code, and my code coverage is going to be higher using an LLM to use it, right? Those things, and I also think the other one would be like readmes, documentation, like go down the list of these things that I think, if anything, it makes it 20% of the effort I needed to do instead of this 100% of effort I needed to do prior. So therefore, I'm more likely to do it, and it leads to hopefully the combination of the two, a better, better commented code base, a better documented code base, better written documentation, and ultimately, hopefully less tech debt or easier understanding if you're onboarding to a code base you've never seen before, right? I think those are powerful tools for software engineers. It's a very good use case for it, and a very good, I think, practical use of AI and software development as well. Um, you know, the other thing I would love for you to talk about, and we're at 42 minutes, so talk to me a little bit about maybe your advice to Nick, skeptical Nick starting out with AI, and what you really knew before, and what would you, if you could go back in time and tell that person some things, what would you tell them? And maybe not just you specifically, but generalize it to engineers.
Yeah, okay. So it's a case of reading the tea leaves. The Everything was there, everything was in plain sight, and you often look past all of that. The ironic thing is that my brother's actually been in AI or ML, like machine learning uh, aspect, for many years, and I've read his book, and this explained it to me very very well, and I still ignored that fact. So it just relied upon me basically having that inquisitive mind again, and basically having that hacker mind again, and just going in there and having a little play and doing a bit of discovery. And this didn't have to be I didn't have to fully commit to any of this. I could have thrown it away and used it as a learning experience. And it would have allowed me to actually um, at least dip my toes in the water at an earlier stage. And maybe I would have been a little bit jaded at that point because the output wasn't that great, but I would have seen a few concepts at least anyway that I would have understood earlier and had been able to actually produce something that was a lot more advanced at an earlier date. So for the general engineer, if you've not touched any AI product or any AI assistant or anything yet, obviously just go and do it. That's the first thing. But also look at some tools outside of your of your wheelhouse first, because that's likely an area where you'll see that you'll hit that phase two quicker, like we talked about earlier, where it's that oh wow moment. Like I didn't even realize I could do that. So don't, if you're like, for example, I was a C++ engineer, don't go and try and write C++ because you're going to be a little disappointed because you are an expert in C++. You can actually write something really good and probably relatively fast. And you could argue whether the model could write it faster or not. But go and write something in a different language. That's the first thing. A language you don't even understand. And you'll start to see, oh, actually, this could actually produce something, and get it to teach you. Get it to teach you what it did. And it becomes very interesting and obvious quite quickly that this is something that can actually, one, speed up learning, but also produce something that you would never have produced in your, like, in a year or 2 years or something. And that gives you the aha moment. Get to that aha moment quicker. You could do this in any aspect of your life as well. I know it sounds very scary, but I do this in finance. Like I try and understand. I try and understand my blind spots in finance and stuff, and ask it questions and understand if my finances are good or bad. because I don't know anything outside of my brain. Like you need to try and gather that information, and to gather that information, you basically have to ask questions. And these models are really good at answering those questions. They may not always be right, so always be skeptical. But it's a really interesting point to gather data.
You know, I like to give this story where I'd say, like, the first thing humans did was write things down on paper or papyrus or whatever. And documents were created to, like, give a, history. And this created kind of us standing on the top of giants because we had all this written history, all these lessons learned. And then the problem quickly became like, all right, we have all this data, all this information. How are we going to organize it? How are we going to sort it? And then you know, we created libraries that did this, Library of Alexandria, or, even now modern libraries. And they created the Dewey Decimal System, if you remember back in the day, to find the information because that became really crucial. And all this is how do we expand this hard drive of the human brain to more things? And then this company Google came along and organized the world's information, their original kind of mission. And it was like, oh, we have this thing. If you remember good old Ask Jeeves before Google kind of came
Mhm.
on, I could ask it in a question that word, but somehow the Google algorithm indexed it and ultimately gave me, you know, 10 books or 15 different sources for me to go make my opinion about that were closely related around what my topic was. But, maybe it was a little off because I don't know, it didn't get the context of what I wanted or whatever and how it done. And then all of a sudden, ChatGPT, LLMs, and it was like, oh, now we have all this information somewhere and we have this thing that we can ask questions to. And it's almost like a semi-human that can kind of know a little bit about all this stuff. And as long as we can query it well enough, it can give us a lot of information and educate us. And this is really where we've expanded this hard drive of human knowledge now, if you can do it. And I think your example of finance or, learning a new language, things like this, the barrier of entry to do that learning now is so low compared to what it was even 3 years ago, right? And now it's just like you said, I think this idea of, do you have a quizzitive mind? Like, are you inquisitive about what's coming up? Do you wanna learn it? Because right now learning is like you have more tools to learn now, especially as adults, than we've ever had in the world. Like, you have information not just at your fingertips, but you have analysis at your fingertips of disparate information, disparate topics, and things like that. And then I think the other side of it is what you said, but realize that you're only going to know how good that output is based on how well you can acquire, how well you can evaluate it. I do think with engineering, things like exploring new languages, it is a productivity accelerator without a doubt. And I think that's what's really, to me, super cool about it because it's like I'm not necessarily looking forward or really think it's possible that AI is going to replace humans and all the things. Uh, but I do think it's going to make humans be able to do a lot more than they could do, especially the soul human, a lot more than it could do, where maybe you needed a team of people to do this before, or a group of people with disparate, I don't know, you needed that finance person, you needed that lawyer, you needed that marketing person, you needed that software engineer that was a front end engineer, you needed that software engineer that was a back-end engineer, and all these different people that would need it. Whereas now, if you know a little bit about that, you can get a lot farther than you could ever do, maybe scary farther than you could ever do. And to me, this is a good intro into like what agentic type development, what agentic type workflows look like now, because your role starts to change when you have all this available and you can set these sort of AI teams up almost, and this is being talked about a lot. Um, why don't you tell us a little bit about what you've seen with, yeah, just agentic coming on recently? You created our MCP server. Why don't you talk a little bit about that and tell us a little bit about how you think that's changing and maybe how vibe codes helped you or failed you as you're experimenting with this.
So I love all these buzzwords. So vibe coding, MCP, agentic. No one really knows what half of them are. Obviously, MCP is a protocol that's different, but um, they are helping the paradigms of all those aspects are helping to an extent. So um, it's 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 definitely becoming a thing where engineers, like you said, front end engineers, back end engineers, I was a core engineer, C++ engineer. We are melding into a more generalist with the use of tools, and those tools are obviously AI tools and other aspects as well. So I feel that my job and pretty much every engineer's job will change to an extent, and I'm not really sure what that role is going to be. Is it creative engineer at that point? Is it like I'm kind of half calling myself an AI developer right now, but I don't know what that is. Like I have no idea. I've heard this concept of creative engineer, and I kind of like that idea because you're taking different aspects of different technologies and platforms and ideas, trying to meld them into one and then producing an output. So it's that creative aspect of it. And I think that's a really interesting paradigm. So this kind of pushes us onto vibe coding, and it kind of touched on this a little bit earlier, which is basically um, if you can explain something, then you can use tools and models to be able to actually output some type of either program or feature very quickly, just to test the waters. So a great example of this was DWS MCP server, which is basically our document processing API wrapped in an MCP server. MCP server basically is something that is a tool or that can talk with models to be able to, not the other way around. Sorry, the models talk to the MCP server to actually perform tasks which aren't really possible with an LLM. So this provided us an opportunity for LLMs to actually start driving document processing. And I thought that was a very interesting concept because many people can't actually software, they can't program, they can't actually access these tools right now. So how do we expand that access via models, via LLMs, basically? So I decided at this point, okay, this is my opportunity to vibe. And I basically just I asked the question. I took an example online of a MCP server, and there's many of them out there. I basically use that as a template, pretty much, and just say, hey, I want to change this a little bit, and I want it to connect with this server. I need it to work with these files, and I want my output to look like this, basically. And I was able to get to a point where I actually have a proof of concept, the V1, V0, whatever you want to call it. And it proved the implementation. No, it didn't prove the implementation. It proved the concept, at least anyway. Subsequently, I went back and rewrote pretty much all of it. But that's not the point. The point is, I was able to get to that point of proving the concept very quickly to actually understand, is this um, a viable solution for anybody right now? And there's just a great example of basically using these newer tools to be able to actually um, speed up my failure rate. And I think that's an interesting one where failure is not a bad thing. Failure is
No.
actually a good thing very early on because you know where you're right and wrong, like very quickly. So yeah, it's good.
Yeah, I think I have a really good friend. People would know him because his initials were in the front of the company we founded together, PSPDF Kit. And I'm really excited to see him. He's diving back into vibe coding and he's doing it the way he does it, broadcasting on Twitter. But it's really interesting the way he has 4 screens and he has,
Yeah.
you know, one agent using MCP to write his PR request, another agent to review them, another one to write a spec for him, another one to implement the spec, another one to do testing of it. And, it's so funny because like, watching him, you'll see him go through points where he's like, "This is amazing, it did all of this, and then I wanted it to do this one thing, it spent all day trying to figure it out and refactored all my code and actually screwed it up," right? It's like the classic story you've heard with people with vibe coding. Um, you do feel like there is something real there. There is some, like, real actual productivity gains there if you know how to interface with this tool and know how to manage these tools, like you talked about it, getting that proof of concept and iterating quickly increased your speed. And even if it increased your failure rate, increased your speed of failure, which ultimately led to you increasing your speed to an actual useful, productive, product. And I think that is super, super valuable. I mean, I always look at this idea like people talk about speed over getting quality right. And it's like it depends on what the error rate is. If your error rate with quality is still like, I don't know, 40% or 50%, and your error rate with I don't know, a speed is 70%, well, you just need to know how fast you can iterate, and speed will still beat out the quality approach. And I think this is the hacker mentality. And so I think a lot of people that are diving into AI and in this sort of vibe, it's perfect for people that have that sort of mentality when they're coming to the problem space or coming to building or whatever they're building. So I think it's really cool how you started out and this mindset, and this mindset's now making you a better software engineer using this tooling now. I think that mindset is super important. Um, I wonder, moving a little bit kind of future outlook, and I don't just want to talk about positive future outlooks. I want to play devil's advocate, and I'll play the let's say the person that's the dissenter on all this. But why don't you first tell me, what do you think positive is going to come in the future? Let's focus on AI and development and AI and maybe workflows, document workflows, things like this.
Positive first. Okay. So I think the positive aspect will be that it democratizes the technology and it democratizes software engineering in general. And this is a great thing because uh, for for decades and decades, this has been locked up in basically garages, basements, as you know from all these stories that you hear about engineering teams and stuff, and they're just slaving away with pizza and Coke. Um, Not everyone is that person. I'm not even that person. I'm slightly atypical, and we're seeing this more and more in engineering in general. Like we don't actually see those types of engineers anymore. We see a diverse set of engineers, which is great. And this technology basically allows us to actually diversify that the people set in general at that point, which is great. It's brilliant because you can then onboard very many different ideas. So if we take the example of product and design and jobs like that, they can actually now come into software engineering paradigms and basically just test the waters and basically say, well, actually, what's possible here is can I actually take my ideas and produce something, either one, just show current software engineers what they're thinking about because it's just a translation tool at that point, or two, even basically create the product themselves. And that's where I feel we're going to go in the future. Um, my job, as I've said, my job as an engineer definitely changes, and that's why I'm kind of saying that this creative engineer becomes a thing instead, rather than a typical software engineer, and that's good. That's a good thing. Like I shouldn't be the one iterating on these tests every single day. I shouldn't be the one writing that same for loop that I've written 50 times in the last few weeks. Like I shouldn't be the one doing that. That makes no sense at all. So that's the positives. Do you want me to
Why
get
don't,
to the negatives?
yeah, why don't we hear the negatives, and I'll add my comments at the end. But yeah, what do you think are the negatives that are gonna come, or what do you think are the negatives already you're starting to see or potentially will see from this? Let's say it's a sea change,
Yeah, so it's a little bit tricky because the this is basically coming from my old engineering brain and the worry that I see code and I see um, patterns being used which are very unconventional and worrying in general. I see some AI generated code and it makes no sense. It's checking error conditions halfway through the function that's just not performant. That makes no sense. You've then got to look at it in a light of, well, does this even matter in the end? Does it produce the output? Does it, is it performant enough? Like it doesn't have, not, things don't have to be perfect. We only, engineers and developers only think things have to be perfect. And I think that's kind of important to think about. Like, just question your perceptions around your knowledge base, basically. In the end, though, I don't know. I think it can free up a lot of our lives and free up a lot of our time. And whether that's a good thing or not, I'm not sure. I really don't know. The pursuit of actually trying to solve a problem is huge for me. Like it, that's kind of, yeah, that's what drives me every single day. If that suddenly disappears somehow, I don't know what I'd do. I'd probably just drink coffee all day or something. I'm not sure what I'd do. So that's the negative.
My older brother put it this way for me, everybody loves automation because if you think about it, most software engineers for the longest time have been automating. It's not anything new until it comes for the thing you love, right? The thing you cherish, and then you don't like it, right? And whether this is autonomous driving or I don't know, it could be word working and furniture building, and now we have IKEA. Or it could be food and you're a chef and really care about the art of food making, and we got fast food. And this is the hard thing. I do think automation is coming for this, and you're really asking the question that you asked is how much does quality matter in the end? And it really depends on what we're talking about in the context. I think to me, the other negative that I've heard, or maybe fear that I've heard, is like, well, we're not going to have junior engineers become senior engineers anymore because they're not going to go through these lessons because everybody's going to be using this. So, like, the whole idea of like earning your stripes as an engineer no longer is going to occur, and therefore all the knowledge that comes in with that is going to be lost. And the example I like to give of this is, well, people don't know how to break down a car engine anymore because you just got a car and you just go to the car mechanic and the car mechanic handles it. And it obfuscates the number of people that know the nitty-gritty details of the problem. I do think if you take it all the way out, I mean, yeah, you could run into the problem that if people don't understand what it's doing anymore, then that could be really bad. I have an opinion about that personally. I do think we've seen it in vibe coding. Like, the first thing you saw was people hard coding secrets keys and, API keys and in their software, and people easily, like, security wise, hacking shit out of it and killing it. Um, I think some of those things will be solved. I do think if you don't understand what it's doing and you don't have it, you can get into trouble. You maybe I don't know you'll be in trouble yet until a later date. We're seeing some of this already. Like, I think this is the whole AI cold war of like black hat use of AI and white hat use of AI to do things. And the white hat's showing us 0 days, 0 day insecurities that we never knew were there, vulnerabilities that we never knew were there, and they're also exploiting, 0 day securities that you didn't know were there. Um, so I don't know. I do think that for me, without getting into the legal aspects of it, because the lawyer side of me goes, man, how are we going to handle copyright and ownership of this stuff? Like, if you vibe code it into a production software, do you own that code? Is a really great question that hasn't been resolved yet. To me, the acceleration side of it is such an added benefit. And I think really, people have talked about this. It used to be as a software engineer, you would have let's say a person come up to you, non-technical person, say, I have a really great deep idea. I'll go in, I'll give you 30% of my company if you build it. And you're like, well, yeah, you don't know how to build it. Now, maybe the building part of it is not as expensive or important or as rare as it was before. So now the idea and like you said, the generalist creativity side of understanding what are you trying to actually solve? How are you trying to solve it? What are ways you can solve it? All of a sudden now is way more valuable. And that generalist all of a sudden becomes way more valuable than maybe it was before. I don't know, just my sort of 2 cents. Why don't we wrap up this and you just tell me in general, in a world now that you've been AI developer, AI engineer, whatever we want to call this, because who knows what it means yet. Um, what do you think are the skills or ultimately the mindset that a person or a software engineer getting into this, really should highlight or should embrace that will make them, you know, be more productive, leverage this better, and ultimately make them a better engineer and a better, create more value in their job, in their personal life, and whatever they do.
Yeah, so I think we've touched upon quite a few of those already, which is
Yeah.
just basically being inquisitive is the first one. Basically because you can learn a lot very quickly nowadays. So that inquisitive mindset definitely helps there. Another thing that kind of pops into my brain, which I know a lot of us engineers in general actually struggle with a little bit, and like you can see it in everyday life, is language. Language is becoming more and more important in the way that we interface, and I struggle with that. And it's something that we have to refine ourselves. So going through this iterative process, if it's whatever it is, vibe coding or just creating a feature in your current code base, like going through those cycles and becoming familiar with the way that you prompt being one thing, but also the language that you're using, like making that become second nature will be quite important, at least in the short term. The long term, I'm not so sure that that is as important because we would hope that models could understand a diverse range of languages and ways of explaining concepts and things. But definitely in the short term, we should be better at explaining our problems and requirements, at least as well. We would.
Yeah, I mean, to me, you said language, and I actually think it's communication because really
Okay.
you have to be able to clearly communicate in very detailed steps. I would actually say more detailed steps than talking to another human, what it is you're trying to accomplish. And, miscommunication happens between humans all the time. I think miscommunication is the iterative cycle with an LLM. It's, no, I didn't mean that. I meant this. Oh, actually, shit, I didn't tell you to do that one iterative step. I left it out. Now try it and do this iterative step. Actually, you just picked a random thing. I really want you to focus on this. And you used an example earlier of like, giving a template of something. That's the one thing that's really cool is like you can communicate with this thing in multiple different ways than just language. You can show it examples. You can say, do it similar like that. And one of my favorite uses of ChatGPT that I've done was when I was trying to think about competing with the competition and I said, take these archetypes, like take a Steve Jobs, but then I said, take a Napoleon and a Sun Tzu and Art of War and apply how they looked at battlefield competition and apply it to software as a service company building. And the fact that it could analyze that and do that was incredible, right? Something that I think would be very difficult for a human. So I think this idea of creativity would be the third one I would put. Like, really embrace a outside the box, approach, and maybe the last one would be bike shedding is gonna hurt you here if you're so caught up in the, like, it needs to be perfect, like you said, in the short term. Well, hey, Nick, I think we've gotten enough content. We've talked enough. Probably cut it down a little bit, but I personally really enjoyed this. Thank you for being my guinea pig. Um, I'm sure there's a lot of nuggets of information and knowledge for people just getting started, or maybe that have been in it. I know there's a lot of people that can relate to your journey and what you did. Um, so yeah, thank you so much for taking the time. If people wanted to get in touch with you or, even hit you up, how would they do that?
I knew you were going to ask that, and I don't have any public development profiles at all. It's just not me. Um, if you want to have a look at Nutrient products and have a look at some of the blog posts that I've written over on Nutrient, obviously go to nutrient.io and have a look at the blog posts there. That's probably the better way of doing it. But
Awesome.
that's me.
All right, man. I think we can sign off. Thank you so much.
Thank you.